Okay, so we're going to talk about radicals now, simplifying powers. I'm sorry, not powers, roots. This is a rule. A radical is simplified when the radicand has no terms that have a power greater than the index. So first of all, let's understand that vocabulary. So here's my radical. This stuff, that's all inside, that's called the radicand. And then whatever number is right here, that's called the index. So we're going to go ahead and try to simplify something that has an index that is smaller than the exponents inside. So starting off simple, let's say we have the cube root of y to the 9th, z to the 12th. So you can see that this is not simplified because the 9, the exponent here of my term, is larger than my index. So 9 is bigger than 3. 12 is bigger than 3. So I think a nice visual to put to this, since we just spent so much time with rational exponents, is to change this to rational exponent form. So that y to the 9th, z to the 12th would be in parentheses, and that cube root would turn into that 1/3 exponent. Well, if you saw this, you would know exactly what to do. You would distribute that 1/3 exponent, that power to a power, you would multiply them, and you would get y cubed and z to the 4th. So how can we go straight from the radical to this answer? Well, what you have to think about is 3 goes into 9 how many times? Well, 3 times. Okay, what's really happening is we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 y's. Now, because it's a cube root, we're looking for groups of 3. So I have 1 group of 3, 2 groups of 3, 3 groups of 3. So that means 3 y's come out. If I think about my 12s, 3 goes into 12 4 times. What's really happening is I have 12 z's. Okay, so there's my 12 z's. Again, because it's a cube root, we're looking for groups of 3. So I have 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3. So that's why I have 4 z's that are coming out. Let's try another one. Let's try the 4th root of x to the 8th, y to the 4th. Okay, so we don't want to change this to rational exponents. Let's go ahead and draw it out one more time. So x to the 8th means I have 8 x's. Now this time it's a 4th root, which means I'm looking for groups of 4. So 1, 2, 3, 4 x's. 1, 2, 3, another 4 x's. So I have 2 groups of 4, which means x squared comes out of my radical, 2 x's. And then y to the 4th, I have 1, 2, 3, 4 y's. Again, we're looking for groups of 4 because the index is 4. So circle those. 1 group of 4 means 1 y comes out. So we don't have to draw it out every time, especially if I gave you like the 4th root of, I don't know, x to the 40th. You're not going to want to sit there and write out 4 x's. So all that's really happening is you're dividing these, okay? 8 divided by 4 is 2. 4 divided by 4 is 1. I personally like to ask myself how many times 4 goes into 8 and how many times 4 goes into 4, because our next step with these problems is going to be simplifying ones that don't divide evenly, and it makes it a little bit easier for me to think about. Okay, so we're going to talk about 3 examples off the notes online. So the first one we're going to do is example C. We're going to simplify the 4th root of 3 over the 4th root of 2. So we can't simplify the 4th root of 3 or the 4th root of 2, so we have to go ahead and rationalize this because there's a radical in the denominator. That's a big fat no. So we're going to multiply by something. Now remember what we're trying to do. Because it's a 4th root, we need to try to get groups of 4. So I have the 4th root. I'm using a 4th root because this is a 4th root. And then my base is 2 because that's what's given in the problem. So I'm going to put a 2 here. Now I can't just have the 4th root of 2. I have to make a group of 4. So right here I really have 1 2. How many more 2's do I need to get me to 4? Well, that's 3. So ultimately you have to see where we're going with this. Okay, if I were to multiply inside here, I would get the 4th root of 2 to the 4th. Understand that that exponent and this root, they're going to cancel each other out to give me just a regular plain old 2 in the denominator where my radical is gone. I haven't done anything on top here yet because I need you to focus on the denominator. So back to the second step, the 4th root of 2 cubed, if I multiply by that on the bottom, then I'm going to have to multiply by that on top. So what's going to happen here is I'll have the 4th root of 3 times 8. So just breaking this down for you, that 2 cubed is where this 8's coming from. And then we can go ahead and multiply those together and have the 4th root of 24. So it's okay to have a radical on top, totally not okay to have it on the bottom. So we have to choose what to multiply by so we get that perfect 4th power. These exponents have to be multiples of each other. All right, I know, that's tough. Let's try another one. We're going to do D. The 5th root of 7 over the 5th root of 2y squared. So it's a 5th root problem. The whole problem's in 5th roots. I can't simplify anything. I can't get rid of any of those pieces in the denominator. Understand that there's 2 pieces I'm working with, the 2 and the y squared. So I'm going to keep it as a 5th root. Now I have 1, 2. I have to think about how many more 2's do I need to get to that 5. Well, that's going to be 2 to the 4th. I need 4 more 2's. Then I have to say how many more y's do I need to get to 5. Because I already have 2 here, because y squared means I have 2 y's, that means I'm going to need a y cubed there. So whatever you multiply by on the bottom, you multiply by on top. So the 5th root of 2 to the 4th y cubed. Now as we think about what the denominator is, that's our main goal, get rid of that radical. So the 5th root of 2 to the 5th, y to the 5th. And that came from 2 to the 1st and 2 to the 4th. We added those exponents to become the 5. And y squared and y cubed, we added those exponents to become the 5. So on top, I could just kind of make this, I don't know, the 5th root of 7 times 16y cubed. So just breaking this down, the 16 is coming from this 2 to the 4th. You're going to want to finish this up by multiplying the 7 times 16. So we'll have 112. Y cubed. So that's my numerator. It has the 5th root in it. That's totally okay. On the bottom, though, the 5th root and the 5th power is going to cancel out, and I'm going to have just a 2y. So we've eliminated the radical from the denominator. All right, one last problem here. We'll look at E. The cube root of 64y to the 6th. So this one's pretty basic. Probably should have been earlier on the paper, honestly. You just have 2 pieces in here. The cube root of 64, you want to understand where that's coming from. 64 is like 16 times 4. 16 is like 4 times 4. I understand I could break the 4's down more, but because it's a cube root, we're looking for groups of 3. And I just so happens I have 3 4's. So 4 is going to come out of the radical. And then I ask myself, 3 goes into 6 how many times? And that's 2 times. Remember, that's coming from having 6 y's. And we're making groups of 3. So how many groups of 3 can I make? I can make 2 groups of 3, which is why I have y squared.